This is Module 12, Lesson 5. We're going to start talking about the mathematical part of this module, which is gas laws. So hopefully you won't find it to be too difficult, simply because we have a formula, and formulas give us a plan. So for today's lesson, it's pretty straightforward. We have the combined gas law. It is on your reference table. You are not required to memorize this in order to take any kind of test on it because it's on your reference table. So let's look at what everything means. The P that's in this equation stands for pressure. Okay? What you're going to have is one pressure and then a second pressure. I kind of think of this usually as like a before and after, and that's how we're going to break it down in the problems. The V stands for volume, okay, and T stands for temperature. Now, it may seem like I'm really picking at things here, but these are all capital letters because a lowercase p is momentum, a lowercase t is time, and a lowercase v stands for velocity. So whether you believe it or not, it is kind of important to make these capital letters. Now, the other thing that you need to do is you have to know the units of these things. And why do you need to know the units? Because as we read these, they're word problems, the units will tell me what I have. It may not say you have a pressure of blah. It'll say a gas at 3 atmospheres is blah, 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 blah. You need to know that 3 atmospheres is pressure. Now, our pressure units for these problems, we can use any of the pressure units that you would like to use. So I'll put the units over here. You may use atmospheres, you may use meters of mercury, or you may use kilopascals. Now technically, I guess you could use torr, but I don't have any of the problems with torr. For volume, with this particular equation, you are welcome to use milliliters or liters. What you have to know, though, is that if I use milliliters on this side, that means I have to use milliliters on this side. They must both be the same. So that is a very, very tricky thing to watch out for. It's easy to forget to do it. If they're not the same, it will mess up your answers. Now, on the temperature part of it, it absolutely must be in Kelvin. It cannot be in Celsius. And if you're thinking, I don't see why it would make a difference, then try the first problem with Celsius and tell me if you get the same answer as we do with Kelvin. You have to use Kelvin. And remember, you have a formula on your reference table that tells you that Kelvin is degrees Celsius plus 273. So how do you turn it into Kelvin? You do this and you just fix it. So here's our first one. It's actually one of the first 3. They're in order. You have my first 3 example problems on your practice page. So what you're going to do is just follow along with me, okay? Here is my recommended way of going about these. I'll give you 2 different ways that you could do it. First of all, you can annotate these problems. Annotate just means you can go through the problem and you can label things as you go. Or the second way is to make a list. So let's annotate, and then we'll make a list as we do it, and you choose which way you like better. It says in a thermonuclear device, that would be like a bomb, the pressure of this many liters of gas. Now, it used the word pressure, but look what's right after it. 0.050 liters. That is a volume. So what I mean by annotate is do like what I just did. And since it's the first one that I've got, I'm just going to call it V1. It doesn't matter what you put on ones and what you put with twos, as long as you group all of the things that should go together together. So you have this many liters of a gas within the bomb casing reaches this many atmospheres. Doesn't tell me what this is, but I recognize atmospheres as a pressure. This is a pressure. So this is going to be P1. It goes with this. This many liters reaches this much pressure. Excuse me. When the bomb casing is destroyed by the explosion, the gas is released into the atmosphere where it reaches a pressure of this. So this is second pressure. This is pressure 2. It says, what is the volume of the gas at that pressure? So it is wanting me to find volume 2. Now, if you don't like this particular way of doing things, then my suggestion to you is to kind of make yourself a list over here. Like V1 is equal to 0.050 liters. P1 is equal to 4.0 times 10 to the 6 atmospheres. Now, some people don't like doing this. Volume 2 is what it's asking for. Oh, no, that should be a P. P2 is 1.00 atmospheres. I honestly don't care which way you do it, but what this will help you do at some point is figure out which formula to use, because if you look at your reference table, you have quite a few of those. So, now if you're thinking about our equation, we only have one at this point, so it's pretty clear that we are using this equation. P1V1 over T1 equals P2V2 over T2. Oops, I don't know how I did that. So, now maybe some of you are going, well, we don't have all three of those. So what am I supposed to do? Like, I don't have the T's. Well, if you are missing part of the combined gas law, what you're going to assume then is that it stays the same. So if I don't have T, we're assuming the temperature doesn't change, we can simply take it out. Should have been T2. We can just pretend that it's not there, and we're just going to plug things into P1V1 equals P2V2. This combined gas law is actually a combination of three different laws called Charles's Law, Boyle's Law, and Gay-Lussac's Law. And each of theirs dealt with portions of these. Like one of them was that PV equals PV. Another one was V over T equals V over T. And another one was P over T equals P over T. They just put them all together. We're given one, and we can turn it into any of those three that we need by taking something out. Or we can put it all in there together. So now what we're going to do is we're going to plug in our numbers where they go. And this is where a lot of students will mess it up. If you don't put the two things that were ones together, like right here, then you'll mess this up. You're going to have 0.050 liters times, somehow this is skipping on me, times 4.0 times 10 to the 6 atmospheres. And then that is going to equal 1 atmosphere times V2. You don't have to put the 2 on there. That is entirely up to you. So, if we do this, what we're going to end up with is 0.05 times 4 to the 6. And what you're going to get is, you're going to get V equals, and you can put V2 if you want to, V equals 2 times 10 to the 5th. But now, we need to do this with sig figs. I know that's such a fun thing for y'all to do. So since we're doing it with sig figs, what do? We go back to these original numbers. This one has 2 sig figs, this has 2, and this has 3. Well, 2 is less than 3, so we're going to have to put a 0.0 on there. 2.0 times 10 to the 5th. Now, our unit, when we divided both sides by atmospheres, what that did is it canceled the atmospheres out and it left us with liters. Now what I'm going to do, because I have students sometimes who I don't think they should have this much trouble with math at this level of chemistry or this level of science, but you know what? Sometimes I get surprised. So what we're going to do is I'm going to go back up here and just simply remind you that algebra comes into play now. How we get the V by itself is that we divide both sides by the thing we want to get rid of. Remember? This is 0, 0. And so what that does is cancels those out. It cancels out the atmospheres, and then we're still back at our answer of 2.0 times 10 to the 5th liters, because liters is what's left right there. That equals V2. Okay? I'm not going to do that in-depth of math on all of the problems. You need to ask me for help if that's something that you need. Now let's look at the next one. At STP, gases have a volume of this. So most people will see this first. A volume of this many liters. So here's a V. We can call that V1. RTP is room temperature and pressure. So here is a T and here is a P. Now, before you go, hey, this is T1 because it's the first temperature I've seen, read the problem carefully. At STP, they have this volume. Well, you should be familiar with this. Sometimes your problems will say things like this and students miss it. Standard temp is 0 degrees Celsius, and standard pressure was 1 atmosphere, 101.3 kilopascals, or 706 millimeters of mercury. I don't care which one you use. So what they're basically doing is they're asking you to compare things at STP to things at RTP. In other words, it's asking you for the volume. I know it says molar, doesn't even matter. They want the volume at RTP. Well, then what I'm going to have to do is compare it to the stuff that's over here on the STP side. So at STP, we have a T of 0 degrees Celsius, a V of 22.4 liters, and a P of any of these things. Well, you see the 1 atmosphere right here? I'm just going to put the 1 atmosphere on this side. The temperature of RTP is 25 degrees Celsius, and the pressure is also 1. So, what do? We put it back into this. P1 V1 over T1 equals P2 V2 over T2. So, do we put in everything? It would appear that I have all the stuff. Now, if you pay close attention, you'll notice that these two are exactly the same. So what you can do is you can just scratch that. It's not changing, and take the p's out. So we have V over T equals V over T. Now that we have the two V's and the two T's, we're still not ready to plug things in. Why not? Because this is in Celsius, and I told you that you have to use Kelvin. So we're going to convert it. This would be 273 Kelvin, because remember our formula is Kelvin is degrees Celsius plus 273. So this is going to be 273, and this would equal 298 Kelvin. We're going to use those numbers. So we're going to put 22.4 liters over 273 Kelvin, and that is going to equal some volume over 298 Kelvin. Now, you can solve this one of two ways. I'm sure you're familiar with cross multiplying. Like you can do 22.4 times 29 or 298 equals V times this. Like you can cross multiply, or you can go ahead and solve for this side, multiply by 298. Like whatever you're comfortable doing. You should have the algebra skills to do this. So I'm doing the math right now in order to get us an answer. And you can see the answers on your paper. I'm just kind of double checking. And I get V equals 24.451 blah, blah, blah. Whoops. So apparently tapping the slides is making them advance. So, sig figs. Well, look back up here. This has 2. We didn't use that. Once you added, you have to look at your Kelvin temperatures. That has 3 feet, and we've got 3. So we get to have 3. So we're going to call this 24.5. I get to keep these. The 5 next to it rounds it up. So my final answer will be 24. I started to write 4. I guess there is no start. I wrote 4. 24 point, what's the highlighter? 5. And our unit will be liters because that's what's up top right there. 24.5 liters. One last problem. 1 liter of a gas, well, here's a volume. We'll call it V1, at standard temperature and pressure. So yet again, it's giving me things. Standard temp is 0 degrees Celsius, and standard pressure could be any of those things that I want to use. But I like the number 1. 1's easy, so let's make it 1 atmosphere. It's compressed to 473 milliliters. Well, this is a new volume. So they've got a liter of gas and they squish it down to 473 milliliters. What is the new pressure of the gas? So they're wanting us to find P2. Well, they never mentioned temperature again. So one of two things. We can either assume that it stays at this temperature, or we can just go, temperature doesn't matter. But either way, temperature doesn't matter because it doesn't change. So we're yet again going to plug stuff into our newly learned formula here. We can take the temperature out, and here you could see a good example of why we're not going to use Celsius, because we would be dividing by 0. We can't do that. So our first P is, I'm going to use atmospheres, like I said, is 1 atmosphere over, oh no, I'm not over, we're not dividing, I've been making too many videos, is 1 atmosphere times our volume, 1 liter. That is going to equal our new pressure, which we're finding, times this. Now, liters, milliliters, I need to make them the same. 0.473 liters. We learned how to do this conversion back in Module 1. So if you have no idea how I just did that, then that would be a good question to ask me or go back to Module 1 and do. Now, in order to get the P by itself, we need to divide both sides by 0.473 liters. So this is gone, liters cancels, whoops. And so that leaves us with a P equaling 2.11 atmospheres. Now, if you chose to do this with a different pressure, you could totally do that. I just didn't give answers with kilopascals or with millimeters of mercury. So you would get a different answer, but it would be appropriate if you did your math correctly. So as you just saw, I'm sure, our next step is to do practice time. So what do you have? You have 13 problems that you could do that have answers included, and that way you could check yourself and you could know what you need help with. So good luck, and you can see me in office hours if you need help.